Hello everyone and welcome to the research results presentation. My name is Mike Fitch with the Ohio LTAP Center here at ODOT, and we appreciate your participation. As we get started, please take a moment to locate the questions box in the GoToWebinar panel. During the presentation today, please use the questions box to send in any questions you might have, and there will be time at the end of the presentation for discussion of questions. With that, we will go ahead and turn things over to Dr. Ala Abbas. Hello.
Hi, how are you, everyone? Thank you for joining this results presentation. Let me start by a quick introduction about myself. My name is Ala Abbas. I'm a professor in the Department of Civil Engineering at the University of Akron. I specialize in infrastructure, materials, and pavement engineering. And this research project falls in this area of specialty. I'll be turning off my webcam now, and I'll be just switching to the presentation, as Mike mentioned. I will be going through my presentation today. It will probably take about 45 minutes to maybe 50 minutes to finish the presentation, and then we'll leave about 10 to 15 minutes for questions and answers at the end. So let me turn off my webcam. Okay, so the title of my presentation is Asphalt Mix Overlay Alternatives for Low Volume Roads on the Local Transportation System. In this presentation, I'll be going over the background that highlights the problem statement, then I'll go to the objectives, the research approach, research results, and then recommendations for implementation. And as I mentioned, at the end, we're going to have basically questions and answers. So pavement resurfacing for low volume roads with extensive cracking is an issue faced by many local public transportation agencies, including those in Ohio. Current options range from chip sealing, which is generally not effective if used on a pavement surface in poor condition, as has been shown in previous research by ODOT, to full depth reclamation, which is prohibitively expensive for most local public agencies, especially for roads with very low traffic. And in here, we're looking at roads that basically have about 500 vehicles per day, maybe 1,000 vehicles per day, with very few trucks per day, basically, on these roads. So another resurfacing option used by some agencies is called mortar paving, which is basically cold mix asphalt that is paved on site and then followed by chip sealing. And several agencies basically reported being satisfied with this mix because it provides a resilient mix that conforms to the existing pavement. However, this particular application is not widely used in Ohio because the equipment is not widely available. As an alternative, hot mix asphalt is more common, and there was an interest in basically producing a mix comparable to the mortar paving mix that is resilient, that can be produced in a traditional asphalt plant and can be placed using traditional paving equipment. So the objectives of the study is to assess the current state of the practice for pavement resurfacing alternatives currently used by local public agencies in Ohio, recommend a cost-effective mix design for an asphalt mixture that is resilient to cracking and environmental conditions prevalent in Ohio, and validate the proposed mix design through laboratory testing and in-field evaluation. So again, the focus in here is really to come up with an asphalt mixture that is resilient to cracking. Even if it cracks, it can basically deform back and not basically make the cracks more severe. So the research approach, this research project was conducted in two phases. In the first phase, we conducted a comprehensive literature review. Then we conducted a survey in which we documented the current state of the practice with regard to pavement resurfacing for low volume roads. And we proposed a mixed design for an asphalt mixture that basically is expected to provide what we are looking for, which is basically a resilient mix. And then we conducted some laboratory testing to evaluate the performance of this asphalt mixture. Now, anything that is tested in the lab in order to make sure that it is usable, it has to be validated in the field, and that was basically done in the second phase. The second phase basically lasted for about 6 months, so the field evaluation is still going to be ongoing, and based on the long-term performance, we're going to basically judge on the performance of the proposed asphalt mixture. So in phase 1, following the literature review, we basically, again, the focus was on what kind of asphalt mixtures are used for low volume roads, including those with cracking and those without cracking. And what we observed through the literature review is that lots of asphalt mixtures use larger aggregates because they require a smaller amount of asphalt binder content. Larger aggregates have a smaller surface area, so you need less asphalt binder to coat them. So that was one strategy for basically using asphalt mixtures for low volume road. The other strategy was going on the opposite direction, which is basically using very fine aggregates so that you can reduce the thickness of the asphalt overlay. If you use large aggregates, you will need a thicker asphalt lift, whereas if you go for a smaller aggregate, you can basically use a thinner asphalt overlay. So these were two approaches. The other approach was basically incorporating high amounts of RAP, greater than 30% and up to 100% in the asphalt mixture, in order to reduce the amount of virgin materials used in the asphalt mixture. The emphasis in all three methods is to reduce cost, whether you're basically increasing the size of the aggregate to reduce the amount of asphalt binder, reducing the size of the aggregate so that you can get a thinner asphalt overlay, or incorporate a higher amount of asphalt, higher amount of RAP, so that you can reduce the amount of virgin asphalt. All of them basically emphasize the cost of the asphalt mixture and the need to reduce the cost. As part of phase 1, again, we also conducted a survey. The survey was basically sent out in September of 2018. We collected the responses in the following month, so we basically were done in October of 2018. And in the following slides, I will be going over a quick summary of what we found in the survey. So we had about 28 state agency representatives responding to the survey, and about 100 local agency representatives responding to the survey. Sometimes with the state agencies, you may have multiple people basically responding to the survey. So for example, for ORAT, you can have central office and some of the district offices responding. So it's not all unique state agencies, but still these are representatives representing specific geographical locations, whether it's within Ohio or outside Ohio. So what did we basically find based on the responses from basically the state agency representatives? You can see in here that chip sealing is, and again, the question in here, for low volume roads that exhibit extensive cracking, how frequently are the following resurfacing alternatives used in your jurisdiction? You can see that chip sealing, we're looking for the yellow, blue, and orange. You can see that chip sealing is sometimes, frequently, and extensively used. And you can see that some of the other alternatives, like a double chip seal, cold in-place recycling, hot in-place recycling, full depth reclamation is reported to be sometimes, frequently, or extensively used. Asphalt overlays tend to be, again, on the high end with a big blue and also an orange. Motor paving is not used by state agencies. Reconstruction is another alternative that they may resort to. At the local level, chip sealing is even more extensively used, and asphalt overlays are also more extensively used. Motor paving, you can see that some agencies reported more use of motor paving than at the state level, and you can see that again there is a lower tendency to basically go to reconstruction, but again it could be an alternative if the roadway is in a really bad condition. Comments about what kind of asphalt mixture or what kind of rehabilitation strategy is used for the asphalt overlay. At the state level, it seems like most of the representative implied using basically 2 to 4 inches, 2 to 3 inches being more common as an asphalt overlay. Thin lays are used by some states, and chip seal is sometimes used as an interlayer to basically prevent reflective cracking. At the local level, up to 3 inches, mostly 2 inches or less. Chip seal, SAMI, or fiber mat are sometimes used as interlayer to basically mitigate cracking. And several basically agencies reported that they're not getting the service life that they used to from these overlays. In terms of what kind of asphalt mixtures or what kind of design is used for the asphalt mixtures, you can see that at the state level, Super Pave is the most common. At the local agency, Marshall is the most common, but some other agencies have experimented with other basically type of mixes. In addition to basically Super Pave, Marshall, Stone Matrix Asphalt, and Open Graded Friction Course, Veam and thin lays and recipe mixes have been used by state agencies. And at the local level, basically, we had 404 low volume thin lays and recipe mixes has been used basically for the asphalt layer. So following the survey, really we identified 2 types of asphalt mixtures that seem to be common basically for roadways with cracking. One was basically based on using larger stone asphalt mixture with a recipe mix design, and the other was basically based on using the 404 low volume traffic, but that one tend to be not really very useful if you're using it on a roadway with cracking. It performs better if you put it on a roadway that has more remaining service life. So we started looking a little bit closer into the other alternative, which is the larger stone mix. Medina County reported basically using a mix design that is similar to the mix design that is used in the motor paving mix. However, it's produced as a hot mix asphalt, not as a cold mix asphalt. The composition of this asphalt mixture was 90% number 57 limestone and 10% natural sand. Aggregates conform to ODOT specifications. They used 58 minus 28, PG 58 minus 28 asphalt binder, and they used an asphalt binder content of 4.3%. And this is again comparable to what is used with the cold mix asphalt that is used in motor paving, 90% number 57 limestone, 10% natural sand. In the case of the motor paving, they don't use an asphalt binder, but rather an asphalt emulsion. But if you look at the residue in that asphalt emulsion, you will basically see that you have a content of about 4.3% binder residue. So in our conversation with Medina County regarding their experience with this particular mix, again, this mix is constructed in a similar way to how the motor paving works. You put basically a 2-inch asphalt layer, and then you chip seal it because it has a larger aggregate stone, so it needs to be surfaced with a chip seal or with another asphalt layer. So in our discussion with Medina County, they reported that basically this mix performed well initially, but over time they felt that it was getting a little bit dry. So that was one of the things that we wanted to basically look at. How can we change the aggregate composition, and how can we basically modify the asphalt binder or the asphalt binder content to better improve the resiliency of the asphalt mixture? So the process for construction for the motor paving and the Medina County Specification 402 is similar. It starts with basically pavement repair. You cannot basically put this asphalt layer on top of a pavement that has clear damage. You need to basically do the pavement repair before you start with the construction. Milling sometimes is needed, sometimes it's not needed, depending on the condition of the existing road. Tack coat, you typically use tack coat if you're dealing with hot mix asphalt. However, you don't need it if you're dealing with mortar paving. From our experience with this particular asphalt mixture, if the mixture is rich with asphalt binder, you can get away with a little bit with less tack coat or even no tack coat, as I will discuss later. But again, the current specifications require tack coat. You need a 2-inch asphalt overlay that is constructed using the Medina County Spec 402. You initially roll this asphalt mixture, you choke it with number 9 aggregates, then you compact it again, and then you go with the chip sealing. So this is the current process for Medina County 402 as compared to the mortar paving mix. So it's very similar. So we wanted to optimize the composition of the Medina County Spec 402, and we followed this approach basically in this optimization. We started by basically looking at different aggregates and understanding their physical properties. We selected different asphalt binder contents to mix with different aggregate proportions, and then we used several laboratory tests to basically evaluate the performance of this asphalt mixture. We used something called the IDLCT, which is similar to the indirect tension or IDT test. I will be showing pictures about these tests, and I will be explaining them, discussing them in more detail. We use this IDLCT, indirect tension test, as a screening test, and if it met the performance criteria, we went through a more thorough evaluation where we used a larger number of tests to evaluate the performance of the asphalt mixture. So the IDLCT test would basically tell us about the propensity of the asphalt mixture to cracking. The AASHTO T283 would basically give us the propensity of the asphalt mixture to moisture-induced damage. Texas Asphalt Overlay Tester would basically give us also performance with regard to fatigue cracking. Asphalt concrete cracking device would give us the low temperature performance. The SCB, or semicircular bending test, sometimes also called the IFIT test, would give us the propensity of the asphalt mixture to cracking. The asphalt pavement analyzer would basically give us the propensity of the asphalt mixture to rutting. So let me go over these individual tests in here. So the IDLCT test, which is again a test that basically looks at the cracking potential of the asphalt mixture. It looks at the load versus deformation curve that is obtained while loading the specimen along its diameter. It takes into consideration not only the loading to the failure, but it also looks into the post-failure behavior. It uses this index, which is called the CT index, to basically evaluate the cracking potential of the asphalt mixture. T is the thickness of the specimen. GF is basically the energy that is basically generated during the loading in the pre-failure and post-failure range. M is the slope in the post-failure range. L is the deformation to get to the post-failure range, and D is the diameter of the specimen. So again, it looks into multiple factors basically to assess the cracking potential of asphalt mixtures. The SCB is similar to the IDLCT test. Instead of using a circular specimen, we're taking a semicircular specimen with a notch in the cut half of this semicircular specimen, and it will give us again load versus deformation. We analyze it in a similar manner to the IDLCT test, and we get a cracking parameter called the flexibility index. Rutting is basically an APA is a device that measures rutting. You have these steel wheels that go on top of a rubber hose that is pressurized to a similar pneumatic pressure to vehicle tires, and basically it goes back and forth on the specimen, and we monitor the accumulation of rutting on these specimens. Texas Overlay Tester is basically this shaped specimen that basically will be pulled and pushed back, okay, to evaluate the fatigue behavior of the asphalt mixture. We're looking at basically how many cycles are required to cause this specimen to crack. The asphalt concrete cracking device is a device that basically used to evaluate the low temperature cracking performance of asphalt mixture. We have an asphalt mixture specimen that is cored in the middle. We introduce an invar material in this middle, and then we put it inside an environmental chamber and we start cooling the asphalt mixture. Now, when you cool the asphalt mixture would want to shrink, but the invar material would prevent it from, and eventually it will crack. So we're looking at basically what is the cracking temperature at which the material will actually crack. In addition to all these tests, since this mixture uses larger stone aggregates, like number 57 limestone or number 57 gravel, we use basically the asphalt drain down test to check for asphalt drain down and make sure that the asphalt mixture is not too rich in asphalt binder. So the idea behind this asphalt mixture is that the more asphalt binder we add, the more resilient will be the mixture. However, the more asphalt binder we add, the more susceptible will be the asphalt mixture to rotting, and the potential for asphalt drain down might be there. So again, we use the asphalt drain down test to check for asphalt drain down and make sure that the asphalt mixture is not too rich in asphalt binder, causing other kind of problems. The criteria presented in this slide was used to judge on the performance of the asphalt mixtures that were used during the screening evaluation and the thorough evaluation. So again, we have the CT index, AASHTO T283, SCB test, Texas overlay tester, ACCD test, and APA test. And you can basically see in here the performance parameter of interest and the corresponding criteria for this particular test. So as part of the screening evaluation, we varied several factors to evaluate their effect on the performance of the asphalt mixture as measured using the IDLCT test. We first varied the type of the asphalt binder. So we kept the same aggregate composition, 90% number 57 limestone, 10% natural sand, and we used different asphalt binders at an asphalt binder content of 4.3. And in this step, we wanted to basically check, okay, the Medina County currently uses 58 minus 28. Should we really be using any other asphalt binder? 64 minus 22 is common in Ohio, but 52 minus 28 is not common. But still, we wanted to check if this asphalt mixture will benefit from using a different asphalt binder. The effect of aggregate gradation and aggregate binder content, based on what we observed in here, we found that actually PG 58 minus 28 was still the best asphalt binder from all these three. So we decided to keep it and start varying the aggregate gradation. So we reduced the amount of number 57 aggregates and increase the amount of natural sand. And along with it, basically look at different asphalt binder contents. And based on this evaluation, we found that from these three aggregate proportions, the 80, number 57, and the 20 seems to be giving us basically the best results. So we decided to move forward with it. But one other thing that we wanted to look at is, okay, we have 58 minus 28. Excuse me. So this is a relatively soft asphalt binder, but what will happen if we make it even softer? So we played with basically an asphalt extender, which is an aromatic oil, and we added different percentages of this aromatic oil to the asphalt binder to see if we get even better, more advantage from using this asphalt binder combined with basically the aromatic oil that we used in this study. And Another thing we looked at is what will happen if we use natural gravel or crushed gravel in addition to limestone. Will we get, or instead of limestone, instead of number 57 limestone, will we get any better performance, worse performance? What is going to happen? And we also looked at basically the effect of RAP if we substitute some of these virgin aggregates with RAP and some of the asphalt, the virgin asphalt binder with RAP binder, what will happen to the performance of the asphalt mixture? I'm not going to go into the results of the screening evaluation because for the sake of time, but I will go into the results of the thorough evaluation. So based on the results of the screening evaluation, we decided to primarily focus on number 57, 80% number 57 and 20% natural sand as the main focus of our mix design. We kept the 90% number 57 limestone and the 10% natural sand as our control because that was basically the material that was used by or that was included in the Medina County specifications. And then we started looking at the effect of the other variables on these on this asphalt mixture. So you can see in here we basically have 4.3. We went into 4.8, 5.3. We looked at the 4.8 with hydroline and without hydroline. We looked at basically crushed gravel instead of basically only limestone. We also looked at different kinds of RAP, audit certified and non-audit certified RAPs. So in the following slides, I'll be going over the results that we obtained for these asphalt mixtures. One thing that you would expect is that with the increase in the asphalt binder content, okay, so in here, these are basically 90% limestone, 10% natural sand, and 4.3% binder content. This is 4.8, this is 5.3. This also uses 80% number 57 and 20% natural sand, 80% number 57 and 20% natural sand. But again, with the increase of the asphalt binder content, you can see that the resiliency of the mixture or the resistance to cracking is going to increase. Okay, so this mixture, it seems like it would benefit from having a higher asphalt binder content used in this asphalt mixture. The use of aromatic oil was also basically showed to benefit us in terms of cracking. So this was something that, again, we were interested to further evaluate. Crushed gravel gave us reasonably good performance. RAP, it depends. Sometimes we did get better, sometimes we didn't get as much benefit from the RAP, and there are other factors that will come into basically play when it came to the decision about basically what to choose. The SCB flexibility index is similar to the CT index that is obtained using the ideal CT test, and the results were also highly correlated, where with basically increasing the asphalt binder content, you can clearly see that there is an advantage of adding more asphalt binder content to this asphalt mixture. The 80% 20% combination also was giving us higher results than the 90% 10% combination. This is really due to the combined effect of the aggregate gradation. We're going finer, so it becomes a little bit more resilient, and we're adding a little bit more asphalt binder content, so it becomes a little bit more resilient. So one thing that we basically came into quickly in this research project is that this asphalt mixture, it probably will benefit from having more asphalt binder content incorporated into it, and it seems like making the aggregate gradation a little bit finer will also be helpful for this asphalt mixture. Again, mixing the asphalt binder with aromatic oil seemed to help a little bit, and the crushed gravel did not seem to significantly affect the results with regard to basically cracking resistance. Cycles to failure. This looks at the fatigue cracking, which is, again, until now we're all looking at cracking, and you can see the same. This asphalt mixture will benefit from making it finer and increasing the asphalt binder content. Okay, and it seems like there is some advantage to basically adding the aromatic oil to this asphalt mixture, and the effect of using the crushed gravel was negligible on this asphalt mixture. These are really good crushed gravel aggregates, and you're looking at more than 90% crush number of crushed faces in here. So these are again well crushed aggregates. RAP again gave us better than the control, but again it was still low for the cracking performance. With regard to cracking temperature, the low temperature cracking, in here we basically got minus 28.5. In here we're getting basically minus 27.2, minus 27.5. The results are really close to each other. When you're looking at the plus or minus 1 degree, the results are really close to each other. You can see that some of these mixtures that contain the aromatic oil, it did actually improve the low temperature cracking, and that's expected because these aromatic oils will soften the asphalt binder and make them more resistant to low temperature cracking, but at the same time it would reduce the strength of the asphalt mixture. So this is something that we need to keep an eye on. So in general, again, I would say most of the asphalt mixture obtained comparable low temperature cracking, a little bit lower for the RAP mixes, but still they are close in general with the other asphalt mixtures. We did not also see any significant issues with basically asphalt drain down. Similar to what you can see in this slide, that increasing the asphalt binder, yes, it helps with rutting, but it also can result in higher cracking. However, since we're dealing with roads that are subjected to very low traffic, we're looking at again 500, maybe 1,000 vehicles per day, and around 10 trucks per day. The occasional type of trucks that maybe a school bus, a trash bus, truck. Then we're not too worried about rutting, but again, similar to what we see in here, asphalt drain down increased when you increase the asphalt binder content, and for some of the softer asphalt binders like those mixed with aromatic oil. But it's still in general, in terms of basically rutting, we felt that this asphalt mixture should be able to withstand common traffic on very low traffic roads. So mixes to be considered for the field evaluation. So based on the outcome of the first phase, again, it was recommended to make the aggregate gradation finer by using 80% number 57 and 20% natural sand. Increase the asphalt binder content to 4.8 or 5.3. Stay with PG 58 minus 28. Look into the possible use of aromatic oil to further reduce the stiffness of the asphalt binder in hope that it will basically be able to better heal once it cracks. And look into the possibility of using crushed gravel in addition to basically limestone as number 57 aggregates. So in phase 2, two sites were selected in Medina County and in Franklin County. As part of phase 2, we coordinated with both counties regarding the information to be included in the bid documents. This happened really at the beginning of the pandemic. So again, I highly appreciate all the cooperation from both counties in making sure that we have the sites for the test sections and that we can continue with the phase 2 activities. We did have a pre-construction meeting and coordination regarding the mix design and the production and the construction activities. When the construction took place, we were present. We also collected some loose asphalt mixtures that we tested in the lab to check to make sure that basically what was produced in the field is comparable to what was produced in the lab. And we did conduct 3 evaluations really every other month for both test sections to look at the initial performance of these asphalt mixtures. To get an idea about the long-term performance, again, it will take place over time. And again, we agreed with both counties to continue with the evaluation at these sites to check the performance of these asphalt mixtures. So the asphalt mixture, the construction in Franklin County took place on Kitzmiller Road in the New Albany area. And this is basically, this site is located in the northeast region of Columbus. The pre-construction meeting took place on June 11th, and the test sections were constructed on July 9th and July 11th, and chip sealing basically took place almost immediately after construction, basically a couple of days after construction. We did have 5 test sections at this test site. In Medina County, the test site is located in the northwest region of Medina County, and it was conducted on Crow Road. We had basically our pre-construction meeting on July 23rd, 2020, and the construction took place on Monday, August 3rd, and there was some interruption due to rain toward the end of the day in there, and we had to basically continue with the construction on Wednesday, August 5th. We had only 4 test sections at this test site. We excluded the crushed gravel combination because crushed gravel is not commonly available in the Medina area, and it will not be used in the future, so we just kept it in the Franklin County test site, but not in the Medina County test site. So in the following pictures, I'll be going over basically the asphalt mixture production, the placement of the asphalt mixture, the compaction of the asphalt mixture, choking, and chip sealing. Again, I'll be going over pictures that were collected at the test sites. So this picture basically shows how the aromatic oil was basically introduced into the asphalt binder line at the plant. Okay, this is a double barrel green asphalt plant, and again you can see in here there is a hose that connects the pump to the asphalt binder line, and this is the aromatic oil that was used. So the amount of aromatic oil was basically metered in to achieve the required percentage of aromatic oil that we wanted to use. And this is basically how the aromatic oil looked like when it was brought to the site. This is basically paving at the site. You can see that this is a relatively coarse asphalt mixture. This is why, again, it has to be chip sealed or overlaid with another asphalt layer. And you can again see how it looks like immediately after paving. I will be discussing the sort of more like do and don'ts during construction at the end of the presentation. So again, this is something that will be discussed. Again, you can see in here, they're basically measuring the thickness of the asphalt overlay, make sure that they can achieve the target thickness. And they basically had 2 rollers on site to basically compact the asphalt mixture. This is how it looked like basically at the end of paving. So immediately after the initial rolling, we basically had the aggregate choking. So you can see the aggregate distributor, and you can see the roller for the aggregate distributor. And you can see that again how the aggregate, the number 9 aggregate is spread in here, and you can see the rolling to basically the final rolling taking place in here. At this particular location, they did have a little bit more aggregate basically placed than they needed to on this side, so they ended up having to actually come and broom it before they did the chip sealing. So again, in here, this is the chip sealing of the Medina County 402, and basically spreading the aggregates after the chip sealing, and followed by compaction. So recommendations for implementation. One of the recommendations was to make the asphalt mixture strictly finer. So we recommended basically changing the lower limit for selected aggregate sieves to make it again strictly finer. One thing that was observed in the second phase is that this mix will again benefit from having more asphalt binder used in it. What will happen is that even if you have a little bit more asphalt binder than you need, again, it will basically drain down within the asphalt layer. So you're going to lose some of that. So again, the higher it is, it's not going to be as bad. But you don't want to go too high, because then you're going to start running into an asphalt drain down issue even in the truck and so on and so forth. So as part of the recommendation between 4.8 and 5.3, it was recommended to go with the 5.3. This way, even if basically the contractor ends up using a little bit less asphalt binder content, you still have a couple of percentage points that are basically included in there. Continue to use PG 58 minus 28. Yeah, use either limestone or crushed gravel, and with crushed gravel in here, we're looking at more like 90% crushed gravel. Use aggregates that have less absorption. Don't go with highly absorptive aggregates, because if you use aggregates that are highly absorptive, then you will need more asphalt binder content. Use of aromatic oil. The laboratory results that we obtained were promising, but in order to make a final decision about whether it's a good idea to use the aromatic oil with this asphalt mixture or not, it will be recommended to continue to evaluate the performance of the test sections and determine basically whether it will be advantageous to use the aromatic oil or not, and at what percentage. Asphalt drain down, it will always be good to include this test as part of the mix design, so that again, if the aggregate that is used is of lower absorption, and you may have any issues with asphalt drain down, you will basically be able to pick that up before construction. But it should be based on the testing that we have, based on the aggregates that we've used. Again, you should be okay with aggregates that are of typical absorption to what we commonly have in Ohio, which are usually less than 2.5% asphalt binder water absorption, less than 2.5% absorption. So construction-related specifications, you will need to place this asphalt mixture at a thickness of 2 inches because the number 57 aggregates have a larger aggregate size than, for example, number 8 aggregates that some of you might be more familiar with as used for a surface course. So if you're going with number 57 aggregates, you're looking at a maximum aggregate size of either 1 inch. Sometimes it can go a little bit higher, but most of the time it's about 1 inch. So the rule of thumb is 2 times the maximum aggregate size. So that's basically the 2 inches. So you usually would want to basically go with 2 inches for this asphalt mixture. If you use anything less than that, your aggregate might start crushing during compaction. So you would want to avoid that by again, making sure that you use 2 inches. Don't overheat the asphalt mixture to avoid damaging the asphalt binder. For both sites, the asphalt contractor actually chose to produce the asphalt mixture at around 275. So I would say 275 to 80 for PG 58 minus 28 was sufficient for that particular day. Again, the temperature was, the construction took place in July and August, so the temperature was favorable. So there was no need to basically elevate the asphalt temperature, asphalt mixture temperature. You would want to go with what is recommended for the asphalt binder, but what I'm basically saying is that you don't want to go definitely higher than that, because then you will be damaging the asphalt binder and you will reduce its ability to resist cracking. Spread the hot mix asphalt when the atmospheric temperature is above 50 and rising. So you don't want, again, to place this asphalt mixture when the temperature is cold, because it has a larger aggregate size, so it will cool down faster on you. Don't place the hot mix asphalt when rain is imminent. If rain occurs during placement of the hot mix asphalt, cease all operations. You don't want any water to be retained in the asphalt mixture, or to basically a heavy rain to fall on the asphalt mixture during compaction or during placement. Ensure that the temperature of the asphalt mixture when delivered is at a minimum of 250, so that you can properly compact it. Use tandem steel wheel rollers weighing 6 to 10 tons for compaction, and don't over compact the hot mix asphalt to the extent that the aggregate particles are crushed or broken. So you have to be very careful with compaction. The key point in here is don't over compact. So you have to be a little bit careful with compaction. Immediately following the initial rolling of the intermediate asphalt course, which is basically the Medina CS402, choke the placed hot mix asphalt using number 9 aggregates at a rate of 10 pounds per square yard. So the aggregate choking will help fill the voids in between the larger aggregates. So when you come and chip seal it, and or even go with an asphalt overlay, you will have less void space that you will lose any emulsion or asphalt binder in. Chip sealing or an asphalt overlay is required on top of Medina County 402 because, again, this is a coarser asphalt mixture. It will have a more open structure, especially at the top. So you would want to make sure that basically the top of the asphalt mixture is sealed so that you don't end up with any damage in the winter due to water, basically filtration and freezing. And with this, this will be the end of my presentation. So maybe we can go to questions.
Yes, thanks, Ala, for the presentation. And I want to remind everybody that the questions box is available in the GoToWebinar. So please feel free to type in any questions you have. There was one question earlier in the presentation about getting a copy of this presentation. And I want to mention that in the handout section of your GoToWebinar panel, we've posted a PDF copy of the presentation slides, and we'll also be sending out a follow-up email with a link to that PDF, and also a link to a recording of this presentation on our YouTube channel. So again, the questions box is open. We do have several minutes for questions, and I see that Vicky Fout from ODOT's research section is also in the presentation here. So Vicky, do you have anything you wanted to add about this project?
I can just let everyone know that our office is finalizing the final report for this project, so it is going to be available on both the ODOT research website and the OREL research website. So you will be able to go there very soon and download the entire report.
Excellent. Thank you, Vicky. And Ala, as we're waiting for additional questions, well, we just have a question that arrived from Greg, and he said, is the purpose of the choking with the number 9 aggregate to prevent rutting with such a soft mix?
The purpose of really the choking is to fill the void. So let me go to this picture in here. So you can see that there is a lot of void spaces in between the larger aggregates. So we're trying to really fill these void spaces so that during the winter, basically when water accumulates on the surface, it's not going to just sit in there and then it freezes. It will cause damage to the asphalt mixture. So the main purpose of the choking is really to fill the voids in between these larger aggregates. So we're more interested in filling the voids than getting the choke aggregate to sit on top of the larger aggregates, but rather again in between the voids, and then when you come with the chip sealing, you will more like seal the surface. So that's the main objective of choking.
Okay, thank you. And while we're waiting for the next question, Ala, were there any parts of the presentation that you'd like to go back to and maybe discuss in some further detail?
I think the main thing is that again the counties will continue to evaluate the long-term performance of these sections, and again that hopefully that will give us more information about how this mix will actually perform in the field. And again, we're hoping to get what is expected from this asphalt mixture, in that it's a resilient asphalt mixture. We may have some we may have some cracking taking place in it, but the hope is that these cracks can more like sort of come back and close themselves because of, again, how the mix is structured and the amount of asphalt binder that is used in it and the type of asphalt binder that is used. And it's a softer asphalt binder that can be mobilized with warmer temperature. So again, this is the hope from this asphalt mixture.
Okay, thanks for that. We do have some additional questions. Question from Matt. Any idea what unit prices were for placement per cubic yard or square yard, however it was measured in the contracts?
Okay. So we estimated that the cost for the asphalt mixture, if used in large quantities, is going to be around $80 per ton. Now, in Franklin County, as I remember, it came at $120 per ton, because again, we're dealing with small sections and different mix combinations, and the contractor had to do some mix design as part of it. So it came at $120 per ton. And in Medina County, because the quantities were even less and we had 4 sections instead of basically 5 sections, it came out, I think, 160 to 200 in that range. I can't remember exactly. But we were expecting that, because that's common for test sections, that they will come at close to almost double what you would expect for a regular paving project.
All right, our next question is from Charles. He says, why did you only try 10% wrap?
Because we wanted really this mix to be as rich as possible with virgin asphalt binder. The hope from this mixture is that, again, if we can get the good field performance from it, to start looking again at the wrap and see if we can incorporate more wrap. But since the objective of this project was really emphasizing the resiliency of the mix, we thought that let's use more virgin asphalt binder and less aged asphalt binder, similar to that is used in the wrap for this particular asphalt mixture. And that basically was observed also in the test results, in that, again, with the more virgin asphalt binder, you're going to get a little bit higher cracking indices. So we did not really want to push the wrap too much in this asphalt mixture. We wanted to more, again, try to achieve something comparable to a mortar paving mix with virgin materials. And then if it works, then we can look again at how can we basically make that happen with more and more wrap.
Okay, thank you. As we wait for any additional questions, I want to mention that in the chat box, we provided links from Vicki with the final report. She mentioned the 2 websites where the final report will be available. Any other comments, Vicki or Ala, as we wrap things up?
I can't think of any.
Okay, at this point, I don't see any additional questions. Again, we will be sending out an email. Oh, I'm sorry, we do have a question from Greg. Thank you, Greg. He says, have you tested any of these mixes with the Hamburg test?
No, we did not.
Okay. Again, we will be sending out a follow-up email that'll have a link to the PDF presentation and also the video recording on YouTube. If there are no additional questions, we want to thank Dr. Abbas for presenting today, and thanks everybody for your participation today. We appreciate it.
Thank you, everyone.